Hello, this is the exit ticket for Module 4, Lesson 27, and I got an email about this assignment. The directions said determine the nature of the solution to each system of linear equations. Okay, and we talked about how the nature, that means does it have one solution, no solution, or infinite solutions. If the system has a solution, then find it without graphing. Hint there, without graphing, meaning algebraically. And today we talked about the substitution method. And if I look at this first one, I notice the first equation is solved for y. Y equals 1/2 x plus 5/2. And if you see that bottom equation, x minus 2y equals 7, well, if we use substitution, then we can take that first equation and plug it into the second one. So I would get x minus 2, I remove the y, and I replace it with the 1/2 x plus 5/2, and then I bring down the equals 7. Doing this gives me an equation with only the x variable, and I can begin solving it. So I see these parentheses here. This is 2 times 1/2 x plus 5/2, but be extra careful because that's a minus sign, so I'm really distributing -2. -2 times 1/2 is going to give us -1x, because these 2's would cancel out. And then when I distribute the -2 to the 5/2, something similar happens here. I'm going to get just -5. Again, the 2's would cancel out. Bringing down the 7, and then I can combine like terms. I see I have x minus x right here. Well, those two will cancel out, leaving us with -5 equals 7. Since this is a false statement, there is no variable left to solve for, this system would have no solution. Which we could have done at the beginning by setting our solving our second equation there and putting it in slope-intercept form, solving for y. On number 2, notice we have an equation, y equals 2/3 x plus 4, and then our second equation is 2y plus 1/2 x equals 2. We could do the same thing here, substitution. Take that first equation that's solved for y. It says y is this. Okay, y does equal this, so that means that we can plug it into the second equation and get 2 times that 2/3 x plus 4, and then bring down my 1/2 x equals 2. And then I just solve, distribute 2/3 times x. Well, this won't be as nice to us as the last one, but that's okay. 2 times 2 is 4, 1 times 3 is 3, no problem. 2 times 4 is just 8, and then I bring down my 1/2 x equals 2. And just like before on the last problem, after I distributed, I can combine like terms. I see I have 4/3 x plus 1/2 x. Okay, and so since we're not afraid of fractions, we can combine those. If you want to use the commutative property to rearrange it so it's a little easier for you to see that those are like terms, by all means, be my guest. So I'm adding 4/3 and 1/2. So I'm going to do a little side note for that. 4/3 plus 1/2. We need common denominators here. I'm going to simply multiply. So this is 3 and this is 2. So I'll just multiply them by each other. Quick and dirty way. So I get 8/6 plus 3/6. Now we have common denominators, and we can just add across the top. 8 plus 3, 11/6. So these two combine to give us 11/6x. Bring down the plus 8 equals 2. And then we continue solving. Solving for x, so subtract 8. 11/6x equals -6. Be careful here. We like to make mistakes like that. 2 minus 8, that is subtraction. You're starting with 2, and you're taking away 8. Okay, I did not count 1, 2, 3, 4, 5, 6, 7, 8. Would take us to -6. Okay, and then finally you're like, but Mrs. Zenos, that's a fraction. What do I do? It's fine. To get rid of fractions, we've talked about how you can multiply by the reciprocal here on both sides. Okay, this will cancel out the 6 and the 11, leaving us with just x. And then on the right side, slap a 1 under that -6, and then it's just top times top over bottom times bottom. And now we have our x value. So this system definitely has an equation. Since we got all the way down to an x value, we have to keep going to find our y value. And this is actually simpler than you might be thinking. So if you remember, we have an x, we have two equations over here with an x and a y. We just need to choose one. I'm going to pick that first one, y equals 2/3 x plus 4. I'm going to take that x I just found, that -3/6 over 11, and I'm going to plug it in. When I do that, I'll have y equals 2/3 times -36 over 11 plus 4. Just multiply top times top, 2 times -36. So I believe 2 times 30 is 60. So yeah, I'm going to get -72 over, and then 3 times 11, 33 plus 4. But Mrs. Zenos, 33, that's fine. Put a 1 under the 4 and just multiply by that crazy denominator of 33 over there. So 4 times 33 we'll get 132 over 3. And then we just add the tops. -72 plus 132, 60. 60 over 33. So that's our y value. So the final answer, and actually I can divide by 11, right? Oh, that's 60, sorry. I said 60 and wrote 66. I can divide those both by 3 to simplify a little more. So it's going to be 20 over 11. So y equals 20 over 11. Our final answer, our solution, is going to be the x value, comma, the y value. Okay, and then the last one here, number 3, I have y equals 3x minus 2, and on the bottom I have -3x plus y equals -2. Now there is an easy way to see that these two are not going to have a solution. If you see, if I solve this one for y by adding the 3x to both sides, I'll get y equals 3x minus 2, which is the exact same thing as this equation. So since these are the same equation, this one would have infinite solutions. Because we got the exact same thing. If we were to graph these, it would just look like one line. I hope this was helpful. Please let me know if you have any questions.